Let's have a look of Lab 4. So before we get started, let's just have a quick look of the document. Do you still remember what have we done in Lab 3? I think so, because in Lab 4 will be very similar as Lab 4, but instead of LOS environment, we are required to put some obstacles between the hotspot and laptop. And we can like observe the difference of them. So do you remember what is LOS, line of sight, and what is the LOS environment? Can have a look here. The LOS, you can see the word here. So basically what we need to do is to put the obstacles, different type of obstacles between the sender and receiver with the different frequency, if we can do. So there are two tasks in this lab. The first one is to capture the RSS data with and without an obstacles. So it's obvious this time we are not required to have different distance between our sender and receiver, but we are required to put an obstacles between them. So here are the details, but I'm not going to read it. You can read it by yourself. It's pretty simple. Just at first, all you need to do is like, let me open draw. So in the first one, let's say this one is your sender and this one is your receiver. The signal will like transmit like this way, right? Never mind. I can make it to a straight line. This one is the sender and this one is receiver. Okay. And at first you should like in the previous lab, we just keep in the LOS environment. So there should have nothing between them. And you can, after the collection, and you can put some obstacles, let's say maybe a sofa or box. You can put a box between them and collect the RSS data again. Does that make sense? So that is what we need to do in the first task. And it asks you to choose 3 different types of obstacles. So you are required to collect like 4 times because at the very first time you should put nothing between them. So this is the first time. And second time you put an obstacles here and start collection. And you choose another one, like say O2 between them. And then you put another obstacles, which is O3 between them. So there are totally 4 collection you need to do. Is that okay? And for each collection, you have at least 500 RSS data in your data set. Let's see if we have any question here. Will the laptop capture no NLOS signals? Can we distinguish LOS or NLOS in the trace file? Basically, we cannot, because we are not very clear to see which packet is in LOS condition, which one is not. But most of the packets will be in the LOS condition. So that's the reason why we ask you to collect like more than 500 packets, so we can easily observe the difference between them. For the obstacles, does it have to be something solid, or can it be something as thin as a paper? Yes. So that is the question we want to ask you, because we want you to try different obstacles. Like you can like put the empty box, and you can have a try of the like thing as a paper, or you can consider the wall as an obstacles. It depends on you, and you can just choose them free. And we need to keep the distance same all the time. Yes, you are correct. We are required to keep the same distance. Okay, so let's have a look of the second task. After the data collection, you also require to plot the RSS distributions, just like the previous labs. We just write down a report and plot some graphs and write down a paragraph of commentary, and that's all. I will show you later. Let's go to the specifications here. So I'm not going to tell you how to collect the data because you have already done the lab 2 and lab 3. So you must be very familiar with that, maybe better than me. So let's see, have a double look, double check of the code. All we need to do is clear the RSS data with and without obstacles here. Uh, yeah, you can see with and without. And we are required to choose 3 different obstacles. So totally it's 4. Does that make sense? So this is 1. Oh, sorry, I made a mistake. This one is 3. This one is 1. And the second thing is we need to make sure the distance is the same. Okay, the same distance. And you may consider, so what is the proper distance for us? It depends on you and your room. So basically, I recommend you to choose like 5 or 6 meters as your distance, but you can have a try and have a look of the difference between different distance with and without these obstacles, and choose the best distance for you. Because if we choose the different distance, the RSS will look totally different. So normally we use 5 or 6 meters, but you can choose it by yourself and explain the distance you choose. And at least 500 packets for ZID, SSID, or all the SSID packets. So we recommend you to capture 500 packets inside your CSV file. So which means already filtered out, which means you have already dropped all the unnecessary packets, and you still have 500 packets. Does that make sense? Because if you only capture 500 packets, it may only take, I would say, maybe 1 or 2 seconds. And after the filter may have only like 10 packets or only 5 packets, which is too less. So we want you to at least 500 valid packets that we can use to plot the graphs. Yeah, let's talk about the packets, how to capture more packets later. I will explain to you how to capture more packets. Let's see, do we have another problem here for more obstacles? Does it have to be? Okay, I already answered this question. And does it matter what distance we leave it as? Like 1 meter, 2 meters? Yes, I think I already explained this problem. The distance depends on you, but you need to explain the distance in your report. And we recommend like 5 or 6 meters. My device capture many 0 dBn signals. Can I just drop them? Yes, I think so, because in theory, 0 dBn, which means very strong signal, very, very strong. I also put this problem in later, so we can discuss it later. That's about 5 minutes worth of packets. It depends the data rate you collect. Okay, so have a look of the report. What should we put in the report? Basically 3 things. The first one is graph. You can plot a violin graph like this. So it can clearly shows that like the distribution of different objects. You can see here. It's very clear to see for the wall, the distribution will around this area, which means the wall may cause the signal strength drop higher. So which means we have less signal strength with a wall. And with line of sight, you can see the distribution is like this. It's a little bit different from other obstacles. So you can write down your commentary of your observation. But this one is only for demonstration. Your plot may not necessarily be the same as mine. And you can also use other plots to like draw the graph. I would say maybe a scatter plot, a bar chart plot. You can use any graph if you think it is suitable for your like demonstration or explanation. That makes sense. So you do not need to follow the my demonstration here. You can choose your own graph if you think it which is not more suitable for your package. And the second one is the table. Table here. You may need to draw a table like this and fill your value inside here and here. So this line is mandatory for the 2.4 gigahertz. It's mandatory for us, but for 5 gigahertz, because some student may not be able to create a 5 gigahertz hotspot, so we are not require you to do this column if you are not able to collect the 5 gigahertz packet. And of course, the commentary. Is there any problem related to this? What type of graph is that? This graph is violin graph. Violin. And search online. Violin plot. Just feel free to use any graph you want. We just have a look of the distribution of it. Do we have to plot the same graph for all cases, or can do individual? Yes, you can do individual, but our idea is to compare them. Like we want to compare the LOS environment, line of sight environment with one kind of obstacles, like compare with them. So you should be able to make them very clear to compare with. So is just the bar graph is enough? I think so. Just make them very clear. It will be fine. Only 2.4 gigahertz in the table is okay, right? Yes. 5 gigahertz is optional. You are not required to do this. But if you can do it, maybe you can get a higher marks. Did you use, but if you didn't do the 5 gigahertz part, you are not meant to lose any marks. So don't worry about that. Did you use Excel to create violin graph? No, I use Python, but I'm not sure we can use Excel to do this, but there must be a way. It should be very easy to plot this kind of graph. And don't worry if you don't know what is violin plot. It's just an demonstration here. You are not required to strictly follow the kind of graph that I use. You can use like scatter plots, like bar charts, or whatever you want. Okay, let's go to the second part. Let's talk about the 5 gigahertz and 2.4 gigahertz. At first, about the difference, I think you have already learned the difference in the lecture, so I'm not going to repeat them. I'm going to show you how to check the frequency. Here. Because I'm using Windows, so I just right click and click the properties here, and we come to this one. So we can have a look of the band here. It's very clear that I'm currently using 2.4 gigahertz Wi-Fi, and the channel is 5. So you can use this tool to check your frequencies. And you may ask how to create a 5 gigahertz and 2.4 gigahertz hotspot. So let's go to the first one, Android phone. With Android phone, it's very easy to create a 5 gigahertz hotspot, just like this. You can get into your configuration. So if your like mobile phone support 5 gigahertz hotspots, then you can choose it and create it. Okay. For Android phone, it's pretty easy. But for the iPhone 12, we may be able to create a 5 gigahertz. Like, let me show you. Here are the example of it. No, it's not this one. Sorry. This one. So you can use your iPhone and have a look of it. Just enter the setting, and in the root menu we have a like personal hotspot and click it. So you may be able to find a maximize compatibility here, an option like this. But you may not be able to find it if you are using the old version of iPhone. You can see only iPhone 12 have these options. and you can have a check of it if you have these options. So if you have these options, then you will be able to control the 2.4 gigahertz and 5 gigahertz hotspot. But if you don't have these options, which means you have a elder iPhone, then you are not able be able to create a 5 gigahertz hotspot, I guess. So don't worry if you cannot. But if you have a Android phone, it will be much easier. And another option that we can use is to use another laptop or desktop you have. So to create a hotspot in our laptop will be very easy like this. Just share my stuff and add it and see you can see the bands here. Can you see that? 5 gigahertz, 2.4 gigahertz. So if I use my desktop to create a hotspot, it will be very easy to choose the band. Here, I can save it and create it. Then I connect this hotspot with another laptop. Does that make sense? So you can use this way to collect the 5 gigahertz packets. So if you are using iPhone, then you are not required to do this, but we encourage you to do this to observe the difference between them. Because if you do this, you may have some advantage in future labs because we are required to discover the 5 gigahertz difference in the future labs. And maybe you can save some time in the future since you can directly use that kind of packets in the future labs. That makes sense? And I think that's all I can say for today. And here are some general questions for this lab. About the feedback and marks for Lab 2 is already available in Moodle, so you can have a check of it. If you find any question and doubts, just feel free to contact us by sending the email or like post it on the forum. And there's only a few packets. Some students might think, say he just be able to capture only a few packets per minute, like let's say 15 packets per minute. So what should I do? So I think I have already told some student in the previous lab. So before we start the capture, let's say we use Wireshark to capture the packets. Before we start the capturing, we need to choose the right interface. And before we stop the capturing, we also need to like open a video, like open the YouTube or whatever video we want to play. And after playing the video, the traffic will have significantly increased. Is that okay? Or you can simply use the ping command with this one, like ping the hotspot with number, a very large number. Then you increase 1 packet per second. That makes sense? And the RSSI or signal strength is positive, like this one. We can have a look of the signal strength. The signal strength is normally a negative value, but sometimes we may be able to find the signal strength is in positive value like this. It's 57 dBm, which is very weird because we can Google it, the signal strength. RSS. Uh, Positive. I can't find the reference here. But with this equation, we can know that the RSS value is always close to 0, but no more than 0. But why this value is positive? This is because we are using some like different interface. For example, my interface may have some trouble on collection the data, collection the true RSS value, because this one is the arbitrary value and it does not relate to any other value of it. So sometimes our like interface will just show it with a value between 0 and 100. So that's the reason why my like interface collect a positive value here. So just don't worry if you got a positive value which is didn't make any sense, but you can still use it. So let's have a look. Do we have another question here? In the future labs, we have to capture 5G signals. We will see. You can have a look of the future labs. For Mac, there might kinds of destination like broadcast, Google, which one should be my laptop, the broadcast. So I recommend you to use the incoming data. For example here, you can see the sample packets in Lab4. After we apply the filter here, you can see we can use them both, but I recommend you to use the incoming data like this. You can also apply another filter here. How can we apply this one? Destination here, you can see here and select. Oops. Oh yeah, but in here we just have a few packets. So I think you can use both of them if you don't have enough packets. It's fine to use all the packets you have. But obviously the incoming data is the like most accurate package. But if you don't have a lot, then you can use all the packets you have. Yeah, just filter your ZID. Yes. You can use the beacon broadcast. Oh, your question is like, which one should be my laptop? It's very easy to find your laptop here. You can have a look. This one is your laptop, and this one is the broadcast, which is different. And that's all for today. So if you have any question, just feel free to ask me. I'll try my best to answer your question. If you don't, just feel free to leave, and we will see you next week. How to make sure we capture at least 500 packets for CID, SSID? Is there any setting we can do from network monitor? Actually, we cannot, like, but you can like start capturing. Let's say you can start capturing new capture like this, start capturing like this, and after like a few minutes, and you think it's enough, then you can press the stop button and output as a CSV file. Then you apply the filter and have a look at how much. Sorry, disconnected. Yes, so if you are not, you fail to capture 500 packets in the first time, then you can collect them in the second time and merge them. Then you will have a large CSV file. Thanks for the answer, King. Just remember to remain the same distance, and you may be able to describe the distance in your report. Thank you. See you next week. Thanks, King. See you.